Hey everybody, and welcome back to another video in this series. So in today's video we will be looking at the LegIK node and implementing that into our GASP from scratch blueprint. So I do want to go over a little bit with that. I want also to kind of want to apologize. I know I didn't get a video out yesterday and I'm getting it out today, mainly because I was trying to take part of a game jam this weekend, just because I wanted to test my skills and whatnot. So that's why it's taking me so long to get this video out. So I will be putting a showcase video on for my little game for the game jam and whatnot, just to kind of show off, even though it sucks. But other than that, guys, let's go ahead and get into this LegIK node, so that way we can talk about it, what each part of it does, and compare it with the control rig that you see in the character's animation blueprint. So let's go ahead and get into it. And what we're going to do, similar to how the game animation sample project does it, is off of the offset root bone, what we are going to do is first let's click anywhere into the blueprint and grab a LegIK node. So it is a generalized basic node that you should have in the default blueprints. It's not like specific to GASP. You should have it in, I believe, the first person, third person, and whatnot. I haven't checked first person, but with the way it comes with third person, I would like to assume it comes with first person and the top down. So let's go ahead and grab that, and what we're going to do in order to make it similar to how it shows up in GASP, all you're literally doing is you're plugging it just like that into there, and then plugging that into the output pose. And that's how you get your local to component and your component to local, because these are separate entities or whatever when you're connecting it. So these are similar in a way where it's like, how you have a print string and you're trying to print an integer and it converts it to string. That's essentially the similar process to this, is that it's converting, or as you can see here, a local pose to a component pose, and then from here to local, because the output pose would be considered a local pose, or your final animation pose. So let's go ahead and look over the LegIK. I'm going to go through all of the settings first and, explain what every part's going on from the, the research that I've done in this. And also we're going to go over, some other stuff. We're going to go over what IK is, yada yada. So LegIK. So when we look at this node, it is a node within Unreal Engine 5's, third-person template or game animation sample project, and it's responsible for adjusting the character's legs so that the feet stay properly planted on the ground or other surfaces, even when the rest of the body moves. It uses the IK foot bones, whatever you set to, like the left foot or the right foot that has like IK foot L or IK foot R to achieve that action. So in breaking down the details of it, so let's start with our settings first, as we have it up here. As you can see, we have a reach precision, which is a tolerance for reaching IK target in Unreal units. So what this does, and what we have it set to 0.01 as the default, is that this controls how close the foot needs to be to the target IK location before the system considers it done. So with it being a smaller value, it just means that, more precise IK placement might require more precise tuning. So setting it to something like 0.01 would be a more precise, precision or whatever, or reach for where your foot, connects with the surface and whatnot. However, I'm going to turn this back into default because, the game animation sample project uses all default numbers. So with max iterations, we have max number of iterations, very simple, very straightforward. However, what it's doing is this limits the number of times the IK solver can try to position the foot. A higher value with it gives us more chances to get the foot in the correct place before it, but can take more time. So 12 here would, be a reasonable compromise between, trying to get precision of where your foot placement's at, comparative to performance. So, the higher the number, the more iterations it's going to do to try to properly place your foot, which will then, come with more processing, which can affect performance, or at least of your character's, animation and whatnot, and cause a little bit more overhead. So 12 is kind of like a reasonable number of iterations from what I've gathered with this setting. So The soft percent length, as you can see here, is default is 1.0, meaning off. Range is 0.1 to 1.0. When set to a value less than 1, will quote unquote softly approach full extension starting when the effector distance from the root of the chain is greater than this percent length of the bone chain. The typical values around 0.97. This is useful for preventing the knee from popping when approaching full extension. So, kind of in my own notes of what I kind of took from that. And so, first of all, let's go ahead and drop this down to 99 because that's what they have in the game animation sample project. But basically, for a simpler explanation of a soft percent length, is that it softens the leg stretch when the IK tries to move the foot to a target. At 99% or at 0.99, the leg is nearly fully stretched, but not quite 100%. It prevents the leg from looking too rigid or unnatural when it reaches. So it allows our character to kind of have like a soft bend in the knee, However, this isn't one of the things that actually helps bend the knees for the IK when you're trying to go on uneven footing. It just, when our character does its stances, it just has like a soft bend to the knee, so it looks, so it doesn't look straight like his leg's gonna go the other way and snap, stuff like that. So now the soft alpha, what this does is that, default is 1.0, full range is 0 to 1, blends the effect of the softness on/off. So what a soft alpha is doing at 1.0 is that this controls the strength of the soft length. A value of 1.0 means it is fully applied. Lowering this would reduce the effect of softening, making the leg behave more like a stiff rod. So you want to have it pretty much at 100%, so that way the leg is pretty much smooth with its animations. The bendings are nice, it's not too rigid, we're not walking like we have sticks up our butts, stuff like that. So now we have leg definitions. So what we have to do here, just like in the game animation sample project, is we do have to add leg definitions for it, and we are going to go over that and do that real quick. So within the game animation sample project, we're going to add 2 because we are going to give it our, our IK foot L, and then our foot bone L, and then our IK foot R, and then foot R for its foot bone. So in here, what we're going to do is under IK foot bone, we're going to look for IK and then IK foot L. Next thing we're going to do is we're going to grab the foot bone, which is just literally foot, and look for foot L, because we want to make sure that they're matching, IK, like inverse kinetic foot bone, and then just normal full kinetic or forward kinetic foot bone, which is just the normal foot L. So before I go into explaining all of these parts, let's go ahead and grab the right one now. So under index 1, what we're going to do is grab the IK foot R, or yeah, I forgot the underscore. So IK foot R, and then for the forward bone, we're going to get foot R, just like that. And we pretty much have like the basic setup to like how GASP has it, but now let's go over these different parts. So within my notes, let's go over what the leg definitions are. So these are the bones that define the legs. Here it's the IK foot L and foot L, and the IK foot R and foot R. These specify the start and end points of the IK chain for each leg. So for each leg, we're keeping the default, so we have number of bone. Let me see if I expand that. Number of bones in limb, minimum rotation angles, foot bone forward axis, hinge rotation axis, enable rotation limit, enable knee twist correction, and twist offset curve name. So what the minimum number of bones in limb does, and why it's set to 2, is this indicates that the limb leg has 2 bones involved in the IK calculations, the thigh and the calf bones. So that's why we have it set to 2. The minimum rotation angle, the reason it's set to 15, is this is the minimum allowed angle for bending the knee. Setting it to 15 degrees ensures the leg can't lock straight but maintains a slight bend. Then with the foot bone forward axis, and why we have it on Y, is that this defines the forward direction of the foot. Here, the Y axis is treated as the forward direction for foot orientation. Then the hinge rotation axis, and why we have it set to none, is that, you know, we don't have a specific hinge axis to define, meaning that the leg doesn't have a strict rotational constraint like an elbow might. So we're not hinging it on something specific. So then we have enable rotation limit set to false, and since this is off, there's no hard limit set on how much the leg can rotate at the joints, because we don't want to set any limits. We just want to keep it basic. We don't want to like constrain the amount of rotation for the joints. And then lastly, for the enable knee twist correction, this is just this is used to adjust the knee orientation automatically, ensuring the leg bends in a realistic way. However, you know, as you could see in the description here that they have in Unreal Engine 5, if I can speak today, the name of the curve used to twist offset angles. So here you would create like a curve float to then add into this to allow a twist offset, you know, for your knee, or, you know, the offset angle. So as you can see, it's useful for injecting knee motion while keeping the IK chain's goal, hand, and root hip locked in place. And it says reasonable values are usually between minus plus 15 degrees, meaning like negative 15 degrees to 0 and 0 to 15 degrees. Although this depends on how far in and out the knee bends in the original pose. So in the game animation sample, they don't have like a curve float or anything to add in there, so we're not going to do that either. But here is where you would create like a curve float to be used within the animation blueprint and set corresponding values with it. However, I'm not quite sure like how you go about doing that when we have value in time. But I need to do more research on that. But as far as me not doing any research at the moment, it was just because it was set to none, so I didn't really have to look too much into it. But I wanted to at least get what's going on here for y'all. So that is pretty much the same for both the indexes, so we're good with the leg definitions. And in the previous video when we discussed the offset root bone, we did go over functions, so you know, just it only applies on the initial update or whenever it becomes relevant or on constantly updating. So now with the performance section, where we have the LOD threshold, where we have max LOD that this node is allowed to run. You know, for example, if you have a LOD threshold to be 2, it will run until LOD 2 based on index 0 index. When the component LOD becomes 3, it will stop and update evaluate. Currently, transition would be an issue and that it has to be revisited. So what this is doing with how I have my notes set is that this just means that the IK logic will always be applied regardless of the level of detail because it's set to -1. A positive value would limit IK calculations to higher LODs only, optimizing performance for distant characters. So you'll probably, if you've noticed anything with like, you know, video games that are open world and you have like stuff in the distance, right? You know how like as the farther you look out, the crappier it becomes. Well, that is your LOD distance, or if I remember correctly, I think it's like load order distance, where you have like 1 through 5, where 1 would be like your best graphics because you're literally up there up close and you get to witness like awesome graphics. But the further out you look in the distance, like the lesser the graphics become, because what it's trying to do is, you know, be performant in what, like, you know, runs, or, you know, how graphically detailed it can be, because you don't need to have like an amazing looking tree out in the distance where it's like I'm not even over there yet to admire it. I'm gonna have it at a low LOD like 5 in order to save on performance until I get over there. So what this is doing for performance is similar to that, where it's like maybe you see a character walking in the distance, but they're looking kind of choppy, right? or maybe like they're looking pretty stiff when they walk. Well, that's because the LOD threshold is set to a higher value, so that way it saves on performance, where it's like, yes, they are animated, they are doing stuff, but until we get closer to them, we're not going to see like the fully suited up, kitted animation of that character. So we just want choppy animations while they're in the distance. So in the game animation sample project, they don't have a tag because we're not referencing it anywhere, but you know, as far as tags go, it's just a reference where you can call it anywhere else. And then here with the alpha, so where we have the alpha input type here, we have the different values like float value, boolean value, anim curve value, but we have it set to float value. And what this is doing is that this just means that the strength of the IK is controlled by a float value, typically a number between 0 and 1, and value of 0 means no IK is applied, and value of 1 means IK is fully applied. Hence, right here, while we have like 1.0 here, this is kind of what it's referring to. So if you don't want any IK applied, you would just change the alpha to 0, stuff like that. So then there's no binding to the alpha, but again, it's the strength of the skeletal control, or you know, the IK applied, stuff like that. But the scale bias, what this is doing, and why you have a 0 and a 1, similar to how they have in GASP, is that this is used to scale and shift the alpha value. So in this case, it's set to 0 shift and 1 scale, so the alpha just remains unchanged. However, if we, you know, increase the shift a little bit, then the alpha will start changing. So then lastly, we have the alpha scale bias clamp. And what this is essentially doing is that it lets you clamp, map, and interpolate the alpha value. So, you know, within GASP, all of these settings are off, and then we just have a scale of, you know, 1, so that way, you know, just kind of remains unchanged, and it's set to, you know, 1 here, and there's no shift because we don't have any biased. So, you know, this is just, you know, these are unmodified values, and it's directly applied without any additional processing. So as far as the dev notes, if we take a look at that, so what I'm going to do real quick is I am going to copy the dev notes over, just because now that we've got a little bit more explanation of what's going on here, I'm just going to throw the dev note into here. So to go over the dev note and what's going on there, that the LegIK, so I'm not going to read this specifically, like just because I have a bit more of an explanation to it. So the LegIK node pins the feet to the positions defined by the IK foot bones, you know, the IK foot L and the IK foot R. These bones can be warped or adjusted using other nodes, like pose warping, to accommodate things uneven terrain, or things like uneven terrain or dynamic animations. And, you know, the local to component, component to local, you know, that what that's doing is it switches the space the LegIK logic works in. This means that the pose might be calculated in a world space or component space at different points, depending on the operation being done. This ensures the leg adjustments remain consistent with the character's movement in scenes. So this setup keeps the character's feet planted realistically on the ground, even when performing complex animations or interacting with dynamic environments. So that's essentially what's going on here as far as a more expansive detail for the simple LegIK process. However, so what they're doing in here though is that it really is just a simple LegIK. I know with some of the notes that I've gathered or the research that I've done and the notes I've put together and what I've seen and read and like kind of understood, is that this should plant the feet realistically to the ground. However, I know you've all seen it within the game animation sample project where, you know, when you try to go upstairs or maybe up a ramp or whatever, that the feet, they don't, you know, they don't collide with it, or they don't stick with the ground. They don't firmly plant themselves on the ground and whatnot. So that's why you would see, you know, shout out to Gorka Games for doing this and the other developers that have done the same thing, where they would input the control rig in order to get this should do IKTrace in order to have the character's feet firmly planted on the ground. So I did go over a control rig and try to, you know, understand what they are doing. And I'll go over that in just a minute because it is an actual process that it's going through. And I tried to put it together myself, but the game animation sample project is missing certain bones. So it's not working out the way I was hoping it to. So it is just better to migrate this into the project and then just call it in the animation blueprint. So basically, let's go over some like specific things or whatever, or let's like compare the actual like LegIK to the control rig, right? Because they pretty much do the same thing. Like we're missing a lot more stuff in a sense. Like we don't have, you know, more iterations or max iterate or precisions and stuff like that. We don't have all this other stuff. However, we do have alpha, you know, and alpha scale biases and stuff like that that we had just went over. However, we have input and outputs where we're essentially able to grab specific data from our character's rig. So, like I said, I'll go over that in just a bit because I have to pull up the actual control rig to show what's going on. But in order to get this input and output, you know, as you can see in here that the LegIK does not have those kind of bindings, so you can't call those, but in the control rig module you can, and the only way to do that is by setting up a control rig class and pointing it, you know, to your control rig that has what you're trying to do. So in this instance, the mannequin has a basic FootIK that allows this to be called. So if we were to change it to say body, and it's going to take a minute because I know, yeah, because it has a lot of stuff, you could see how the amount of pins change and like what they actually do. Like that's why I knew it was going to take a while once I, you know, just clicked on it. But yeah, it's getting a lot more data or data pins or return values to do stuff. So, you know, depending on how you set up the control rig is, you know, what you would like be allowed to call in or modify within your animation blueprint. However, we're trying to keep it simple and we want to do the basic FootIK in order to get the return Boolean value from there, so that way we can plug up whether we're falling or not. And again, like I will be going over it. So first, before I get into it, because we do have to switch into the control rig blueprint for me to show you, let me just explain, you know, how the LegIK node compares to the control rig. So, you know, they both provide ways to manipulate character bones, but they differ in flexibility, complexity, and use cases, and here's a comparison between them. So with the LegIK node, the purpose of the LegIK node is a specialized solution designed specifically for handling inverse kinematics on legs and is optimized for common leg-based IK needs, like ensuring feet stay planted on the ground, adjusting for uneven surfaces, handling slight changes in leg positions during animations, etc. Its ease of use is it's straightforward and easy to implement. As you just saw, we were able to just throw it in there and go. So, and you know, since it's designed for legs, most of the settings are already tailored for this purpose, so you don't have to adjust too much for basic functionality, and it's great for simpler projects or quick setups where you need reliable foot placement without too much overhead. Then the flexibility, while the IK node is effective, it's limited to legs and doesn't offer much flexibility beyond this scope. You can tweak how the IK behaves with parameters like reach precision and soft length, but you're essentially working with a fixed framework. Then its performance is that it's highly optimized for legs and runs efficiently even in complex animations. It uses fewer calculations and offers parameters like LOD thresholds to adjust performance, like, you know, off in distances. And then the use case for a LegIK node is that it's ideal for leg placement and quick foot IK setups in third-person games like walking animations or simple foot adjustment for dynamic environments. So that's what it should do and be capable of. However, I had tinkered with every sort of thing in here that I can, you know, try to find, and I have yet to figure out how I can get it to actually do a proper foot placement like how the control rig does it, where, you know, on stairs or inclined slopes that the leg bends. I still have not found it. I'm still playing around, and I will definitely do an update video or something on this just to be able to show people how to do that without having to do a whole migration of a control rig basic FootIK into the game animation sample project. It will happen. But other than that, let's go over the control rig and how it compares to the LegIK. So with a control rig, it's more of a generalized solution. So the purpose of it is that the control rig node is a more general and flexible tool that allows you to create custom rigs and manipulate bones in any part of the skeleton, not just the legs. You can design IK setups for legs, arms, and other body parts, and it's designed for complex character rigging, animation, and interaction systems. The ease of use of it is while control rig offers more power, it requires a deeper understanding of rigging and animations, and you will need to manually set up controllers, constraints, and logic for the IK. However, by doing this though, it gives you a fine-grained control, but it takes more time and expertise to configure properly. So like I said, I will show you where it's getting this from and how it looks and do a basic overview of what's going on. So with the flexibility of a control rig is that this is where it shines. You can create highly custom rigs with IKs and FKs, which are forward kinematics, or a blend of both. It's ideal for animators who want full control over how different parts of the character move or respond to dynamic interactions. And you can also add custom logic to handle specific scenarios, such as making sure that the hands follow a target while the body adjusts accordingly. The performance of a control rig can be more resource intensive due to its flexibility and potential for complex setups. However, you have the ability to optimize it, and you can selectively apply it only when necessary. Since you have control over the calculations, you can decide how complex the rig needs to be. So a use case for this would be perfect for complex characters where you need more control over multiple parts of the body, or for creating custom IK setups that go beyond simple leg movement. So it's widely used with, like I said, cinematic animations or advanced gameplay mechanics and dynamic character interactions. So when to use each. This is another thing I've looked into because this was something I found in someone's post on like when to use one or the other. So for a LegIK is you want to use it when your needs are specific to leg movement, and you want a fast, simple solution. So, like I said, with how we just discussed it, is that you can literally just throw it in and it should help out your characters, your leg stances, plantedness, and like other stuff, just to get a basic like system up and running for that. But then, a control rig is when you need like full skeletal control, including legs, arms, head, or like custom systems. So now to kind of get into it a little bit, like let me explain what inverse kinematics are, which is the IK, which is what this is doing, and what the control rig has a part of with the basic FootIK. So inverse kinematics is a technique used in animation or robotics to control the movement of joints like bones in a skeleton, so that a specific part of the structure, for example, a hand, foot, or arm, reaches a target position or orientation. So a simple way to understand it is that imagine your arm. It has several joints, which includes your shoulder, your elbow, and your wrist, and each of these joints can rotate in certain ways. If you want to move your hand to a specific position, instead of manually adjusting each joint like how you would in forward kinematics where you would move the arm joint by joint, inverse kinematics lets you define the in position, or where your hand should be, and the system does an interpolation or calculates how all the joints, your shoulder, elbow, and wrist should move to get your hand to that position. So that's what inverse kinematics does, and that's why it's really nice compared to your FKs, which is your forward kinematics, because that you have to define the joint by joint movement in order to get your precise animation, so it's a little bit more work. But with inverse kinematics, it's like, well, if I hold my hand to my side, but I need my endpoint is to have my hand straight out in front of me, but flipped over as if I'm trying to accept an offering or something like that, then you would just define where its start point is, and then define another key, where it's like my hand at the end point is where my hand is extended outward and, turned over to accept that gift. So then it will do those automatic animations or calculations or interpolations for you. So, like how it works in practice is you would define where the end limb is, like I always mentioned. And then the system calculates the necessary rotations and positions of the joint that leads up to the endpoint. And then for the output, the joints rotate appropriately so that the limb bends and moves naturally to reach the target. So that's just a little bit more of a technical talk of it. So that is pretty much kind of what it is. I do have some examples, but I don't want to take up too much y'all's time with this video, as I just kind of wanted to go over the difference between the LegIK node that is used in the game animation sample project with the control rig, you know, that's set within the third person template or first person template, etc. Right? So, you know, with talking about that, let me show you briefly the control rig, right? So in order to find the control rig that is used within here, is we're going to go to content, and then we're going to go into mannequins, and then you're going to go into rigs, and then right here where you'll see BasicFootIK is the control rig that is responsible for our, you know, feet being planted on the ground and on like slopes, stairs, and whatnot. So let me open it up first, and we're going to briefly go over kind of what's going on. I haven't made my way fully through this. However, I do have a basic understanding of what's going on, even though it does look very, you know, disturbing, scary, whatever. It's actually not as bad as I thought. It just looks weird. So, you know, as anything, your forward solve is your, you know, your event that occurs within this. As you can see, event for driving the skeleton hierarchy with variables and rig elements. So it's just the event that starts off the, you know, the animation processing or the rigging processing. And then you have a sequence node. I don't know why they have an outdated sequence into this, but basically if you were to type in a new sequence, you do have that, and it does, oop, did not mean to do that. And it works in the same way that this does, but I don't know why we have an outdated one. I haven't delved that much into it to find out. So then basically where your IKTrace is doing is it's essentially this right here, because this is a function, you know, called foot tracing. And what this is doing is it's actually doing a sphere trace, you know, on the foot or on the root. So as you can see here is we have a get transform of the bone and then get transform bone here. So we have two different parts. However, what this is doing is it's, as you can see up here, is getting the animation root bone that is, you know, made and assigned within this the character rig. So what we're trying to do is feed like our IK foot bone here, which is our the input is, where was it at? Yeah, a rig element key type. Not quite sure exactly what that does, because I haven't dabbled that too much into animation to know what a rig element key type is, but I can only imagine it's kind of like a struct in a way, but specific to animations. Because as you can see here, we get some like other stuff like type, name, the space that it's used in, whether it's a local or global space, and then the initial. However, we're using it in a global space, and we're connecting it to the root of our animation. Then we get a second transform bone, and we are calling a bone and the root, overall root of the character. So I've tried implementing this in the game animation sample project. However, you have to construct these bones, or at least within the rig, you have to construct them. So like how you would construct a control rig is you would go into your characters, I believe it would be under meshes, yeah. And then you would go to your skeleton mesh of your actor, you would right click on it, and then you would create, and you would create a control rig right here, which will then, you know, prompt this control rig, which they called mannequin BasicFootIK. However, when you get into here, one of the things that you will need to do is do a construct, which I'm surprised I don't see it in here because I had to create it in the other one. But the construct goes through and makes all of these bones in order to be called on in the get transform, because if you don't do the construct and spawn those bones in, then you just can't call them. Because right now we can call them because everything is there, it gets the parents and everything, but in GASP you have to spawn those bones. So then what it's doing is it's getting the location, you know, so the translation, which is the location of the IK foot bone or whatever the foot bone that we pass in. So in here, you know, we pass in the IK foot bone L, and then in its second one, the IK foot R. and we're getting the location of that and passing it through, but then we're like adding an offset to the Y, so that way we pass it in there, and then we're offsetting the Z values of both of these respectively by 30 and 50, and doing a sphere trace with those that will then become our offset that we call. So then we can set up our Z offset target for our left foot and then our right foot. So then what this is being used for is then we start doing interpolations where, you know, kind of like in the game animation sample project of how it does its line tracing, you know, from the character to the level block traversable to the floor, you know, back floor, like whatever. This is essentially doing the same thing, although it just looks weird. And we're just modifying our, you know, right foot target to our offset right foot, because then we are going to end up calling these offsets, you know, after they're all set. And then we're going to modify those, you know, newly constructed offset values. And then we end up calling those into our full body IK. So that way it, once the trace hits the floor, discovers it, it modifies our bones to attach to the floor. So I can try to do a more in-depth talk about this maybe in a future video, but I'll have to do a lot of research on what's going on, just because, again, I'm not that fluent with control rigs or animations. I'm more fluent within the functionality as I, you know, do the setups and stuff like that. But I just wanted to show you a basic rundown, or give you a basic rundown of what's going on and where it's actually doing the tracing in order for our foot to be, you know, to come down on the stairs or on like a ramp. So with that, what we got going on now is, so with this, we're essentially done with the LegIK video, and it's a very simple setup, very quick and easy, dirty. You just throw it in there, and game animation sample project, they keep most of the defaults, except they set the soft percent length to 99% just for a slight bend. But after that, what I would also do too is I would take this and throw it into the back here just for more precision essentially, or just straight up bypassing the LegIK. However, what I do like is that the LegIK, I like it being in there because it gives the simple like IK stuff to then just be passed into the control rig and get better, more precise modifications. So as you can see when we, you know, play around, that our feet aren't, you know, too far up. It looks like they're firmly planted on the ground, and we have the slight bend. As you can see right here what's going on, you know, we're doing our IK traces, you know, that you saw in the control rig blueprint. So let me go ahead and pull up the game animation sample project, and let me show you how you would actually implement this in there. I do want to shout out Gorka Games for figuring it out. It actually is very simple and straightforward. However, there's, you know, two different methods to it, and like ways that I like doing it, especially since we already have good stuff set up. So let me go ahead and pull over my game animation sample project and pull that up, and I will be right back. Alrighty guys, I am back, and as you can see in my game animation sample project, how I do have a ramp that is set right there, so that way I can show y'all how this is working, right? So if we go ahead and hit play with our game animation sample project, and we have just the basic LegIK, right? You can see how we float up, and you know, it's not doing proper tracings and whatnot. So, you know, with this, like I said, I messed around with the LegIK a lot because I wanted to try to figure out how to do this. However, in order to get this set up, unfortunately, you do need to do those traces. Like it's pretty much almost unavoidable from what I've seen. I am trying, like I said, I am trying to figure out if there's a much simpler way of doing it, because if I can figure out how to do it with just the LegIK, I will make an update video on it. It will happen, but as far as what I've done, tested, and everything like that, I don't think it'll actually allow you to do that without setting up tracing. So that is, I feel like, the unfortunate part to this. But in order to implement the basic foot IK from the mannequin into your character, one of two ways you can do it is you can go here to add, and you can do add feature or content pack, and then you can add in the third person template into the project. So then what this will do is it'll create a folder underneath characters called mannequins, and then you'll go to rigs, and then you'll have the basic FootIK. However, that's not what I did. I migrated these assets because I didn't want everything else that came with the third-person template. So, just to migrate those things over, essentially you would just come into here, and where it's located, you'll go to content, characters, mannequins, and you'll go into rigs and look for the basic FootIK. And then just like how you would with everything else, you would go to asset actions and you would migrate it into the content folder of your game animation sample project. So when you do this, it only gets the stuff related to that control rig that you can just throw on over. And that's exactly what I did because, like I said again, shout out to Gorka Games, that I did not want to add the entire feature pack because I didn't need more resources like within and taking up, bloating up my file size and stuff like that. So I only migrated what I wanted, which was the control rig along with the other parts because it wasn't going to take up that much. So now, as you can see, I do have the basic FootIK, and with here, surprisingly, you don't actually have to you don't have to retarget them because, for one, you can't anyway. But it's not like you have to set the mannequin or the UEFN mannequin up to it. What you can do is you can just go into your ABP sandbox character, and you would right-click into the space and look for control rig. And we want this one right here where it says miscellaneous and then control rig. And then, as you can see, we get the similar control rig that is in the third-person template. So then once you've migrated your assets or added them through the feature content pack, then you can, once you have the control rig, you can come into here, and what you're going to do is you're going to scroll down your details until you see control rig class, and then you're going to then look for the CR mannequin basic FootIK and add that in there. Once you do that, you will have an input and output pin that now has should do IKTrace, just like that, because that is one of the values that we had saw when we took a look at the actual functionality within the control rig. So we're going to check this box just so that way we can get the should do IKTrace. And here, what you would do, there's a couple different ways you can do it. You can grab an is falling node, or sorry, you have to grab the character movement, and then you would grab an is falling node, and then you would assign a not boolean to it, because the reason why we're doing this for our trace is because we want to make sure that we are not falling, because in order for the trace to work, as you saw in those Z offset values like the 30 and 50 that we saw in the control rig, is that those are values doing its sphere trace from the foot node to the floor. So if we're in the air, then there's no reason to be doing an IK trace to be able to find our flooring and stuff like that. So when we're not in the air, it's literally going to turn like the alpha off. It's going to set it to 0 just so we can do our jumping and stuff. And then when we're back on the ground, that we grab the IK trace again, so that way it does a sphere trace to the floor and then grabs where our foot should be. So that is one way to do it here. However, if you want another way to do it, what you could also do too is if you go to your states and you drag out movement mode, and then you drag off of here a not equals enum, so this first option right here, you can then change it to on in air, and then throw that in there as well. So that way, anytime we're in, as long as we do not equal in air for our movement mode for our, UEFN mannequin, that we can also do the should do IK trace, and then appropriately modify our feet to be able to be touched to the floor on a slope or stairs or whatever. So I'm actually going to leave it like this just because it's fewer lesser nodes and lesser logic that it has to use, rather than having to get a character movement, get the is velocity, and then get a not boolean and then assign it in there. It's probably just as simple, but because we have stuff like this already set up, that's why I chose to do it this way, just because I feel like it's more performant in a way. So with that being done and said, what I'm going to do is, again, I want to keep the LegIK. However, if you do not care for this, since they essentially kind of do similar things, you can just connect from the offset root bone into the source and then out the source into the post history trajectory node here. So you can do it that way, but for me personally, because this gets the basic IK legging stuff, I want to then throw in the control rig for the basic IKTrace part, just to add like a little bit more nuance to our leg tracing. So here we can just call advanced, or we can call it control rig IK LegIK. We'll call it control rig LegIK. Just like that, so at least we know what it's doing. Match it up to here, and then, yep. So there we go, guys. We basically have the control rig set up in the game animation sample project. So now if we were to look at it, right, if we go ahead and hit play, when we go onto the ramp, you will now see that we have the basic IK movement. So as you can see, what it's doing though is it's not modifying the actual footing position, like, you know, the bend of the foot. We are still getting, you know, some weirdness to it, but at least our legs are modified to be able to, you know, attach itself or place itself, you know, on stairs or on an angle, whatnot, and actually look good. So if you wanted to modify the feet, I'm not quite sure how to do that. However, I do know that if you wanted to do that, it would be a simple thing. It should be something simply within the basic FootIK, where more than likely you're going to have to modify the root bones. So here we go, perfect. So this is what I wanted to show you, where here is the construction event underneath the event graph. How they're spawning in just like a lot of different bones, where we're getting like weapon R, spine 5 for chest, you know, left chest, right chest, you know, hand root, pivot, world, we're having items go and be apparent to another, you know, so we have a lot of stuff going on in here. That is what's causing it, and this is where I was having trouble setting it up normally within the game animation sample project. So with this at that point, it is just better to do that, and I realized I just closed it out. But other than that, I feel like it would just be spawning bones in there for your feet, and then modifying the values within the trace to be able to bend your foot, or not your foot, but where your ankle, it hinges on your ankle and whatnot, to be able to, you know, rotate or actually be on top of, you know, stairs or at least a slope with your feet bending. So other than that, guys, that is pretty much it as far as what we had to do. I don't know why that minimized. So that is pretty much it. And as far as a basic setup for the, you know, the LegIK, and a discussion with the IK and how it compares to the control rig. So just for simple stuff, if you ever start your third-person game from scratch or your first-person game from scratch, it would probably be better to just throw in a LegIK for the moment, so that way you at least get that. And then as you get more complex into control rigging and stuff like that, that you can finally create your own basic FootIK. However, like I said, it's a little bit more advanced, a lot more research I'd have to do. So other than that, guys, I hope you enjoyed the video. If you did, please check out my other videos and hopefully my future videos to come. But other than that, y'all have a great rest of your day and take care.